So far in our study of algebraic equations, we've been looking at how to solve or isolate one variable at a time. However, in algebra, you can work with a variety of different algebraic formulas, and formulas describe algebraic relationships between two or more variables. In this lesson, you will learn how to rearrange formulas to isolate or solve for different variables. Now, when you're working with a formula, there's two different ways that you could approach it. The first way is looking at the known values for variables, which are given to you usually in a word problem or question. You could substitute or plug those numbers in first into their appropriate locations, and then simply just solve the equation like you normally would for whatever variable it is that you're looking for. Or another way that we could work it is we could start by rearranging the formula first to isolate the required variable that you're looking for. And then once you've kind of put everything into the right spot, then you could go ahead and plug in the numbers that are given to you in the question. So in this lesson, we're actually going to focus on using this second method. We're going to rearrange the formulas first and then talk about how we would then solve the equation. So while it may seem complicated to rearrange a formula, you're actually just going to isolate the variable in the same way that you would solve an equation. So in the following examples that we're going to work on, we are going to rearrange each formula to isolate for the indicated variable. So let's take a look at our first question. So the formula that they've given us is D equals A plus B. So we don't know what these letters represent, but that's okay. We don't really need to know. But what they want us to do with this formula is isolate for A. So that means they want you to get A by itself. So right now when I look at this, I see that A is located here on the right-hand side of the equation, but it's not by itself on the right-hand side. There is also a B or a plus B attached to it. So normally, if we were solving this like a regular equation, what we'd want to focus on getting rid of or removing is this plus b. It's on the wrong side. We want to move it away from the a. So if we want to move it over, we're going to take this plus b and bring it over to the left-hand side. Now remember, anytime you move a term over the equal sign, the sign will become the opposite. So if I take a plus b or a positive b and move it over, it's actually going to become a negative b. So now on the left-hand side, we're going to have d minus b, which is equal to a. And so by doing that, we've gotten A by itself. We have isolated for A. So this would be the formula that you would use, D minus B, if you wanted to solve for the letter A. In question number 2, we have a brand new formula. C is equal to 2 multiplied by pi. This is the Greek symbol for pi, multiplied by r. Now you might recognize this formula, you've probably seen it before. We use this formula to calculate the circumference or the perimeter around a circle. So for this particular formula, they are asking us to isolate for r. So we want to get the letter r by itself. So the first thing that I notice when I look at this formula is that on the right-hand side, there are 3 different terms here. There's a 2, there's this pi symbol, and there is an r. And they are directly attached to each other. So when they are side by side, kind of squished together like this, we know that they're actually being multiplied together. So this is actually 2 multiplied by pi multiplied by r. So remember that in order to isolate, we always want to do the opposite or use the opposite operation. So the opposite of multiplication is actually division. And so if I wanted to get r by itself, that would mean that I would need to get rid of this 2, and I would need to get rid of this pi symbol. So the only way I can do that is to divide both sides by the 2 and by the pi. So I'm going to put in a bar on both sides, because remember that whatever you do to one side of your equation, you must do to the other side. And so we're going to divide by 2 and by pi. And we're also going to do that on the left-hand side. Okay, so let's actually do some of this division. So let's start with 2 divided by 2. Well, 2 divided by 2, that's 1. And we know that we don't really have to write that number 1, so we're just going to leave it out. We also have pi divided by pi. Now, in case you've forgotten, the actual value, number value for pi is 3.14. So really, if we're saying pi divided by pi, we're saying 3.14 divided by 3.14, which is equal to 1. And again, do we have to write that 1? No, we don't have to. So really the only thing that's left over then on the right-hand side is the letter R. Now on the left-hand side, we've got c divided by 2 multiplied by pi. There's nothing that we can do here. There are no like terms. There's nothing that would divide together. You can't divide a letter by a number. Can't divide by a variable by another variable. So really the most that you could do here is just recopy it. So we're going to recopy c divided by 2 pi. And we've successfully isolated for r. We've gotten r by itself. So if I wanted to solve for r, or the radius of my circle, I could simply just take the circumference and divide it by 2 times pi. So this is a formula set up to solve for the radius of the circle. In question number 3, our equation is y equals x squared, and they ask us to isolate for x. So they want us to get x by itself. Now, right now, the x is attached to this exponent 2. So this is an x that is being squared. So remember that anytime you're solving an equation or even isolating for a variable like we've been doing, you need to perform the opposite operation. So we know that the opposite of addition is subtraction, we know the opposite of multiplication is division, and vice versa. But what's the opposite of something squared? Well, the opposite of something squared is a square root. So if I want to get rid of the squared on my x, I need to square root it. Now remember that whatever you do to one side, you must also do to the other side. Okay, so on the left-hand side, we've got the square root of y. Now, you can't put that into your calculator because you don't know what the letter y is. There's no y button on your calculator. So the most that we can do here is just recopy that. So we're going to recopy the square root of y. And on the right-hand side, you are square rooting x squared. Now remember, these are opposite operations. A square root is the opposite of a square, or an exponent of 2. So they're really just going to cancel each other out and they're going to disappear. So if the square root and the exponent disappear, all that's left is an x. And so you've isolated for x. You have x by itself now, and it is equal to the square root of y. Our next formula is y equals mx plus b, and we're asked to isolate for the letter x. So we want to get x by itself. So again, remember, you can approach this as you want to get rid of anything that is attached or beside the x. So what you could do first is you could start by kind of covering up or blocking out the term where you actually have the letter x. So that would be this mx term here. So all that's really left over then, or what we need to get rid of first, is this plus b. And in order to get rid of it or remove it, you need to bring it over to the left-hand side. Now remember that anytime you bring something over the equal sign, you need to change the sign or change it to the opposite. So if I have a positive b and I bring it over to the other side, it's actually going to become a minus b. So that's going to leave me with y minus b, which is equal to m times x. So we still don't have x by itself. It's still being attached to this letter m. And remember that when they're attached side by side like this, this represents a multiplication. So the opposite of multiplication is a division. So in order to get rid of the m that is currently attached to the x, we need to divide both sides by m. Okay, so remember that a letter on the top and a letter on the bottom, those are just going to divide and give us 1. Okay, you could also think of it as they kind of cancel each other out. Okay, so you can kind of scratch it out there. So all that's going to be left over on the right-hand side is an X. And again, on the left-hand side, you just got a lot of different letters. You don't know what any of these letters represent. They're not the same letters, so that means they're not like terms. You can't put them together or do anything with them. So all you can do here is just recopy the expression. So in order to solve for the letter X, you would have to perform Y take away B, all divided by M. All right, let's take a look at a formula that has a fraction, or we could look at this as a division. Remember that the bar represents the division operation. So this says V is equal to W divided by Q. And they are asking us to isolate for W. So we need to get W by itself. So remember that when we learned how to solve simple equations, we learned that, well, the opposite of division is multiplication. And if we want to get W by itself, we need to get rid of the number or the letter that is attached. So what is attached to W? It's Q. I don't want this Q. I need to get rid of it. So to get rid of it, I'm going to need to multiply both sides of my equation by Q. So I'm going to put a Q on the right-hand side, and I'm going to put a Q on the left-hand side. So I just kind of squished it in here. This is not an exponent or anything. It's just, think of it as directly being beside the letter V, okay? So on the right-hand side, we've got Q divided by, I'm going to extend this a little bit. So we've got Q divided by Q. So again, you've got a letter on the top, a letter on the bottom. Q divided by Q is just 1. Or we could say that they cancel out. So all that's going to be left over on the right-hand side is a W. On the left-hand side, we've got Q multiplied by V. So again, we've got two different letters. We don't know what they represent. We don't know what numbers to put in their place. So the most that we can do is just recopy. So we've got Q multiplied by V. And so we've successfully isolated for W. We got W by itself. If we want to solve for W, we could just take Q and multiply it by V. All right, here's a formula that actually does have a fraction built into the formula or into the equation. So we've learned how to solve equations with fractions, and so the same rules are going to apply here. So in this equation, we are told that K is equal to 1/2 multiplied by M multiplied by V squared. And we are asked to isolate for V. So before we even worry about the letters, we need to get rid of that fraction. So our rule is to look at the denominator of our fraction, the bottom number, and we have a 2. So that means I need to multiply both sides, every term, by 2. So I'm going to put a 2 here on the left-hand side and a 2 here on the right-hand side. So we're actually going to simplify this a little bit. So on the left-hand side, we've got 2 multiplied by K, which is 2K. On the right-hand side, we've got 2 multiplied by 1, which is 2, and 2 divided by 2, well, that's 1. Now, we could write the 1 in if we really wanted to, and then we recopy mv squared. But again, remember in math, we don't have to write out this 1, so I'm actually just going to erase it. So what we really have left is 2k equals m multiplied by v squared. So now again, we were asked to isolate for v. We got to get v by itself. So we're still not there yet. We're not done. So the next thing that you could do, like we've talked about before, let's kind of cover up this v squared. So if we're covering up this v squared, well, what's right beside the v squared is an m. and the m is being multiplied together with the v squared. So if they're being multiplied, we need to perform the opposite operation in order to get rid of the m. So the opposite of multiplication would be division. So we are going to go ahead and divide both sides by m to get rid of it. So on the right-hand side, remember that we have m divided by m. That's going to give you a 1, or we can say that they, just cancel out. So on the right-hand side, the only thing that's going to be left is v squared. On the left-hand side, we've got 2k divided by m. Nothing we can do with this. Can't put any of these letters together or simplify it in any way, so we're just going to recopy it. So are we done? Have we isolated for v? Well, not quite yet. We still don't have v by itself. We still have v squared. So now, how do we get rid of this squared? Remember that the opposite of something squared is a square root. So we are going to square root both sides of our equation or our formula. And so what are we left with? Well, on the right-hand side, the square root and the squared are going to cancel each other out and they're going to disappear. So all that's going to be left is a lowercase v. On the left-hand side, again, nothing you can really do here, so you're just going to recopy. So we've now successfully isolated for v. We've gotten v by itself, and it is equal to the square root of 2 multiplied by k divided by m. All right, we've got one last question to do, and I'm going to ask that you give it a try. See if you can figure it out. You've got c equals 5 over 9 multiplied by f minus 32. So this is actually the formula to change a temperature in Fahrenheit into a temperature in Celsius. Now, they want you to isolate for f. This is actually the wrong f. It should be a capital F, since that's what they use in the formula. So you need to isolate for the letter F. You want to get F by itself. So go ahead, pause the video, see if you could try to figure out how to do it, and when you're ready to see the full solution, come back to the video and hit play. So if I were to get a question like this, the first thing that I would want to do is get rid of the fraction, because fractions are super messy. We don't like to work with them. So I'm going to check the number that's in the denominator or the bottom of my fraction, and I see a 9. So that tells me that I need to multiply both sides of my equation or formula by 9. Okay, so on the left-hand side, we've got 9 multiplied by c. That's 9c. And on the right-hand side, this is going to read as 9 times 5, which is 45. 45 divided by 9, that is 5. So we have 5, and we still have this bracketed portion, f minus 32. All right, the next thing we need to do is get rid of the brackets. Now, this is a distribution issue. So we need to take this 5 and distribute or multiply it into the bracket. So we are going to go ahead and recopy the 9c, and now we're going to multiply. So 5 multiplied by f would be 5f. And then we have 5 multiplied by negative 32. So 5 times negative 32 is negative 160. So now we've got an equation that looks a lot more simpler. No more fractions, no more brackets. All right, so now we want to get the letter f by itself. So that means this negative 160, it's got to move over. So if we move that over, that's going to become a positive 160. And finally, we've got a 5f term. So if I want to get 5 by itself, I need to do the opposite of this multiplication, which is going to be a division. So I need to divide both sides by 5. That's going to cause these 5s to cancel out. On the left-hand side, nothing really I can do here. Okay, I can't put together 9c plus 160. Okay, you cannot divide these numbers separately. So all you can do is just recopy it. So we've got 9c plus 160 divided by 5, which is equal to f. So we've got an f by itself, we've isolated for it. And so the formula to calculate a temperature in Fahrenheit would be 9 times C plus 160, all divided by 5.